All right, you guys, here's section 2 of your SLO review. First, we're going to start off with barcodes and with credit cards. Remember, there was a couple differences with barcodes and credit cards, depending on what number we multiplied by, and then there was an extra step for the credit cards as well. So with this, we have two barcodes. One of them, we have to find the check digit. The other one, we have to verify the check digit is legit. So the first thing we need to do is we need to add together every other number. And if you can see right here, I put 6 numbers in right there, and there shouldn't be 6 numbers, but we're going to roll with it. So in this case, I'm going to add together all these numbers and not the last one. So 3, 5, 3, 6, 2, and 8 is what I'm guessing that is. 3 plus 5 is 8. 3 more is 11, 17, 19, and then that's an 8, or is that a 1? 19. And 20, excuse me, that's a 1. So that's going to give us 20. It's a barcode. Bar's got 3 letters, so we're multiplying times 3. That's the way I always remembered it. And we get 60. I'm then going to go back. I'm going to add together all the numbers that we didn't add together to start with. 2 plus 8 is 10, plus 5 is 15, plus 7 is 22, plus 4 is 26, plus 6 more is 32. So we end up with 32. We're going to add those two numbers together. 60 plus 32 gives me 92. And we need to figure out, what do I need to get to the next 10? My next 10 would be 100. It's going to take me 8 to get to the next 10. So D has to be 8. And I recognize there'd be a little bit difference of the look because I messed up with the 6 numbers. My bad. I'm going to do the same thing over here just to verify this check digit is legit. So 1 plus 7 is 8, plus 6 is 14. Plus 5 is 19, plus 4 is 23, plus 1 is 24. We're going to multiply times 3. 24 times 3 is going to be 72. And then we're going to add together the ones we didn't circle. 8, 2 is 10, 5 is 15, 8 more is 23. I'm guessing that's a 3. 26 and 32. 6 more is 32. Hopefully those numbers are right. But 72 plus 32 gives me 104. What does my check digit need to be? My check digit needs to be 6. This is 4, so this is not valid. That's how I would handle those. All right, now credit cards. Credit cards have a little bit of a difference. There's going to be some similarities. So the first thing we're going to do is we're going to add these numbers together, every other number. So 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. 9 more makes 7 is 16. 9 more makes 25, excuse me. 1 more makes 26. Plus 3 is 29, plus 5 is 34. Now these credit card, think of CC, there's 2. So times 2. And 34 times 2 is going to give me 68. So now we need to go back through those things that we underlined and see how many of those are bigger than 4. So that one's not, that one's not, that one is. So there's 1. There's 7, so that's another one. So there's 2, there's 3, and there's 4. So we're going to add 4 to this, and we get 72. The last thing I go back through, and I'm going to add together all the ones I didn't underline. So those that are in green. 2 plus 4 is 6, plus 6 more is 12, 8 more is 20. Plus 0 is still 20, plus 2 is 22, plus 4 is 26, plus 6 is 32. And so we'll end up getting 72 plus 32 is 104. That's kind of crazy. They ended up being the same thing. And it should be 100. So this, really, we could have maybe not added those together, but this should be 100 right here. And it's not, so not valid. Our check digit should have been 100, so that's going to make this go back 4. So digit should have been 2, not 6. All right, so this one I'm going to do a little bit different in case that first part was confusing. We're still going to add these chunks together. So 2, 5 is 7, 1 more is 8, 2 more is 10, 16, 19, 22, 24. So we end up with 24. Still times 2 is going to give me 48. I go back through and see how many I had bigger than 4. So 1, 2, that's it. So plus 2 and we get 50. And then I go back through and add the other ones. 4 and 6 is 10, 14, 19, 26, 30, 32. And so, excuse me, we take the 32 that we got from adding all the ones in blue plus the 50 that we got from earlier. We get 82. This check digit needs to bring us up to the next 10. Our next 10 would be 90. So our check digit is 8. All right, Venn diagrams. There was a couple things you need to remember about Venn diagrams. Number 1, is it a probability or is it a number answer? Number 2, pay attention to that word only. It's going to make a big difference. And we talked about working backwards, which is going to work most conveniently. So in this case, I'm going to work backwards. It says you polled 110 people and found out that 75 are taking math, 15 are taking math and English, and 8 are taking neither. So first thing I'm going to do is label math and just ENG for English. And I'm going to start backwards. 8 are taking neither, which means they can't be in the circles. So there's 8. 15 are taking math and English, has to be in both circles. So there's your 15. 75 are taking math. So we're talking about this circle has to have 75 in it. It's already got 15. We ain't got room but for 60 more. So there's 60 on the outside. And then all it tells us is that there's 110 people altogether. And so I'm going to do a little side work. 110, take away 60, take away 15, take away 8. So that's 50, 35, 27. And so over here would have to be 27. So the first thing I got to do is fill out my Venn diagram. Now that I've done that, I can go ahead and come over here and answer these questions. I'm going to go ahead and highlight this, letting you know that the green circle is English, the red circle is math. So it says how many students are taking English. Well, these guys are, so are them. So we put those together, 15 plus 27, and we get 42 people. Notice it's a how many question, so it's not a probability question. The next one, though, says what is the probability that a person only takes English? So only takes English is these 27 people right here. So 27, however, it's a probability, so we have to write it out of the total, 110. You might see that as a decimal. I'm not going to worry about it. I'm going to leave it as a fraction, but just in case, all you would have to do, divide 27 by 110. So the probability that somebody takes math or English, well, these people take math, so do they take math or English? Absolutely. These people take both. Do they take math or English? Absolutely. These people take English only. Do they take math or English? Absolutely. So we need these 3 sections. If I were to add those together, 60 plus 15 plus 27, I would get 102. Once again, it's a probability question, so 102 out of the 110. The last question, math and English, that's my intersection of 15. So then we have to have only 15 out of 110. All right, so I move to the next one. This is a 3. We are going to start backwards. It says home economics class surveyed that many students, 1,125, about the meals they ate at the dormitory cafeteria. The class found the following information: 25 ate breakfast, 25 ate only breakfast, 15 ate only lunch, 50 ate only dinner, 60 ate only lunch and breakfast, 225 ate only lunch and dinner, 500 ate only dinner and breakfast, 240 ate all 3 meals. And so first thing I'm going to do is label mine: dinner, lunch, breakfast. If you put your letters in different spots, it's going to look a little bit different than mine, but we still should be able to use ours to answer these questions the same way. So the first thing I'm going to go is backwards. It says 248 all 3 meals. So in all 3 circles, we need 240 people. I'm going to go ahead and highlight these real fast, just so you can see. Dinner's going to be green. Lunch is going to be blue. And breakfast is going to be red. So that's going to just help us kind of differentiate some stuff later. But so 248 all three, which means it has to be in the green circle, the blue circle, and the red circle. That's the only section that is. Pay attention to this word. If we go backwards, it says 508 only dinner and breakfast. So only dinner and breakfast means that it can only be in the green circle and the red circle. Can't be in the blue. So we're not doing the subtraction that we used to do. We're just going to fill in this spot with 500. If we keep going backwards, it says 225 ate only lunch and dinner. So once again, now between the blue circle and the green circle, we're going to have 225. And then it says 60 ate only lunch and breakfast. So blue circle, red circle, we have 60. 50 ate only dinner. So that's only the green circle, 50. 15 ate only lunch. So that's only in the blue circle, 15. 25 ate only breakfast, so that's only the red circle, 25. And then it gives you this final amount of 1,125 students. So to figure out what goes on the outside, or if we need anybody on the outside, we're going to have to add these chunks together. So I'm adding 50 plus 225 plus 15 plus 500 plus 240 plus 60 plus 25. Well, that's not all the 1,125 people, so I'm going to take 1,125, which was my total that we got from right here, and I'm going to subtract how many people I already know, and it leaves me with 10 people. So that 10 has to go on the outside. So notice all of these are probability questions, which means all of them are going to be over 1,125. So just like writing sentences when you were a kid, when you got in trouble, I'm going to go ahead and put that just to remind myself, hey, these are all probabilities. All right, so in this case, what's the probability that they ate only breakfast? Well, these are the only breakfast people, so that's 25 over 1125. You might see that reduced. Don't freak out. Just divide and get your fraction reduced. Probability that they ate at least 2 meals. This is where it gets kind of crazy. You guys struggle with this word at least. At least means they can eat 2 meals. They could have also eaten 3. So we're talking about this guy, this guy, this guy, and this guy. So we're going to add those chunks together. 225 and 240 is 465. 500 is going to be 965, 60 more. 965 and 60 is going to be 1,025. Ate only 1 meal, so only 1 meal means they can only be in one circle, so that's this person, and these people. So 50 plus 25 is 75, plus 5 more is going to be 80. Exactly 2 meals has to be in 2 circles, so those people, 500 and 225 is 725, 60 more is going to be 785. And did not eat in the cafeteria. That's these 10 folks right here. Didn't eat in the cafeteria, 10 out of 1,125. So big things you got to keep in mind, that word only, going backwards, keeping in mind those strategies, whether it says probability or a how many question, little things like that. All right, tree diagrams. So with the tree diagrams, you're either going to be given probabilities or you'll be given a situation where you're going to have the understanding of what your probabilities are going to be. Obviously, if you have the opportunity to have a boy or a girl with a baby, that's a 50-50 shot. If you're flipping a coin, it's either going to be heads or tails, it's a 50-50 shot. Rolling a dice would be 1 out of 6. All of those types of things would be probabilities that you should know. Otherwise, they're going to give them to you. So when we're drawing our our pizza tree diagram, I'm going to start with my sizes. So we have medium, large. Medium has a 0.3 probability. Large has a 0.7 probability. If I go to the next, I have to choose crust. So crust is either going to be thin, TH, or traditional, TR, and that's an option no matter if you get medium or large. Thin and traditional. And the probabilities don't change either. This is a 0.4 probability of getting thin. This is a 0.6 probability of getting large. It's the same thing right here. And then your toppings, extra cheese, Italian sausage, and pepperoni. So each of these have to have a little 3 that comes off. So I'm just going to put a C for cheese, an S for sausage, and a P for pepperoni. And you end up with 0.2, 0.5, 0.3. That would come off of all of these as well. I'm going to kind of expand that a little bit so we don't run out of space. 0.2, 0.5, 0.3. Sorry, it's difficult to see, I know. Expand this one out so we got space. Excuse me, that's sausage. Cheese, sausage, pepperoni. 0.2, 0.5, 0.3. Cheese, sausage, pepperoni. 0.2, 0.5, and 0.3. So notice a couple things that these probabilities should add up to 1 in each of these levels. If they don't, you're probably screwed up somewhere. So just make sure that that's happening. We could find the probabilities that go on the outside, but I'm not going to just for time's sake. But we can go ahead and use this tree diagram now to be able to answer these questions. So how many combinations are there? You're going to add the end of your leaves. So how many leaves do we have? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different combinations. Notice that's a how many question. It's not a probability question, so we're good to write it like that. Where y'all screwed up when dealing with your probabilities is you didn't multiply when you went down your branches. You added those sections, and you ended up with some funky stuff. So in this case, we're going to multiply probability of medium, thin, and extra cheese. So we're going to take this path. Let me use a different color so you can see it. So medium, thin, extra cheese, which means we have to multiply 0.3, 0.4, and 0.2. So my calculator real quick. 0.3 times 0.4 times 0.2 gives me 0.024. That's the probability that I make that happen. The next one's large, traditional, and any topping. Since my toppings don't matter, all that matters is that I'm looking at a large and a traditional pizza. So I'm going to go down large and traditional. We could have multiplied all these and added them together, but really it's simpler just to go ahead and say 0.7 times 0.6 since that's all we're worried about. So you only have to go as far as you need to go. So that's a 42% chance or a 0.42 probability. Probability of medium, once again, we don't even have to multiply anything because that's a 30% chance or a 0.3 probability. And then the last question says, if you order 30 pizzas, how many do you expect to be medium, thin, and extra cheese? So we're going to use this probability from up here. So we had 30 pizzas times the probability that that pizza will happen. So 0.024. I'm going to hit our calculator up real quick. 30 times 0.024. And we end up getting 0.72. So if you think about it in context of the situation, maybe one pizza. And like we said, a lot of times people use this, like pizza places will use this to try to decide toppings, amounts that they need, things like that, what they need to be ready for. All right, so here was the 50-50 chance. You got boys and girls. So the tree diagram for a family that has 3 children. A lot of us messed up on this, and we saw 3 children, and we went 1, 2, 3. That's not the case. You can't have a boy, a girl, or a dog when you have a baby. So you have to think about it as 3 levels of kids. Your first level, you can either have a boy or a girl, and that's a 0.5% chance for a boy, 0.5% chance for a girl. Every level after that, the same situation is going to happen. You can have a boy or a girl, and a boy or a girl. So 0.5, 0.5, 0.5, 0.5. And then your third kid can still be a boy or a girl there, boy or girl there, boy or girl there, and boy or girl there. All of these are going to be 0.5, 0.5, 0.5, 0.5, 0.5, and so forth. The reason why it's nice that all of these are matching is because earlier where I said I didn't want to waste the time and find all of these n probabilities, I can do it one time and it's going to be the same for all of them. So I'm going to do 0.5 times 0.5 times 0.5. We get 0.125. And that would be the same for each of these situations. So that's going to help us when answering these questions. So what's the total number of possible outcomes? Well, we got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. What's the probability of having 2 girls and 1 boy? So 2 girls and 1 boy could be boy, then girl, girl. So there's 1. I'm going to put a little check over here. So boy, girl, girl. We could have also done girl, girl, boy. So there's another situation. We could have done girl, boy, girl. So there's a third situation. That's the only way we could have 2 girls and a boy, are those 3 scenarios. So your options are, you can either do the probability times 3. So 0.125 times 3, because it's going to happen 3 times, and you'll get 0.375. Or since 3 of the possible outcomes end up with that scenario, and we had 8 possible outcomes, let's see if this works. 3 divided by 8, we still get that same thing. So whether you're using your leaves to your advantage, or if you're finding your probabilities and using those to your advantage. Probability of having no boys, that's only one situation. Girl, girl, girl. So that's going to be 1 out of 8, or 0.125. So you might see it, I'm going to write both of them. You might see it both like that, because that was one situation out of the 8 possible outcomes. All right, this next question has nothing to do with that tree diagram, but it's just another probability question. It says if there's 5 shirts and 7 pants, how many combinations of shirts and pants can you create? We could have done the same thing up here with boys and girls to find the possible outcomes. The first situation, there was 2 possible outcomes. The second situation, 2 possible outcomes. And the third child, 2 possible outcomes, which will give us 8 total outcomes. Excuse me. So I'm going to use that technique with the number 24. 5 shirts, 7 pants. So 5 times 7, 35 combinations. All right, so that's the end of section 2.